Next, let's turn to React 19. Andrew and Josh will share more about what's in this release in just a moment. This release builds on the foundation of concurrent rendering that we established with React 18. So to put these features in context, it helps to understand how we got here and our approach to solving problems with React. So what makes UI so hard? Many of the most complex challenges in user interface development are really problems of coordination and scale. For example, synchronizing application state with our UI is a giant coordination problem. There's an exponential number of state transitions to consider. And our approach to problems like this in React is to turn these coordination problems into declarative APIs, like JSX, where you describe what should happen, and React manages the complex coordination on your behalf. We solve the scaling challenges by ensuring that our APIs compose. You can wrap one component in a larger component until you build up an entire app. Declarative, composable UI. Let's see a couple more examples. In 2019, Meta's UX research showed that users perceive sites as faster if our content loads all at once, rather than popping in individually as things are ready. But how do we know when everything's ready? That's a complex coordination challenge, coordinating all the data loading across the entire page. React Suspense is a declarative API that lets us describe what data we need and what loading states we're willing to show, and lets React do all that complex coordination to show those loading states appropriately. Suspense also incorporates the results of this UX research, balancing the desire to show content quickly with the need to show a complete experience. So by using Suspense, you can build a site that takes advantage of all this UX research out of the box. But these types of coordination and scaling challenges aren't just limited to the client. Some of our logic belongs on the server, and some of it needs to be shared between the server and the client. Server components make React's same declarative, composable approach to UI work seamlessly across the server and client, allowing us to have easy access to back-end data sources while also continuing to render interactivity where we need it. This lets developers continue to break down their applications into small, reusable pieces, regardless of where those pieces should live. In React 19, we're continuing to expand on this theme, solving more places that currently require complex coordination. To tell you more, here's Josh.
Hi, I'm Josh. I'm a member of the React team at Vercel. And today, Andrew and I are going to give you a sneak peek at some of the great features that are coming to you in the next major version of React. We're going to tell you about some improvements to server rendering and Suspense that simplify some tricky coordination problems with HTML. We're going to cover some long-anticipated improvements to hydration. We're going to talk about a new core concept in React we call actions. And finally, we're going to give you an update on some welcome changes to JSX. All right, let's begin. The React team takes special interest in solving problems that require coordination across an application. But data loading and UI states aren't the only aspects of an application that can benefit from built-in coordination. During the past couple years, I spent a good bit of my time digging into the challenges of HTML document ordering to make declarative composable HTML possible. Now, I know what you're thinking. That's kind of silly. React already allows you to write composable HTML, and that's true, but it's for visual content. But HTML conveys document metadata, scripts, style sheets, and preloading hints for fonts, images, and more. Imagine an app where some routes render articles. Our article component is a great place or natural place to put page-specific information, both the visual article content, but also things like the page title and the styles that are specific to the article's visual representation. But consider where these elements will end up in your HTML document if you were to actually render them like this. They're almost certainly not going to be where you want them to. The title is document metadata. That belongs in the head. The style sheet is deep within the document, and the browser can't start downloading it as early as it could, and will likely paint before loading the style sheet, and you'll end up with a visual bug called flash of unstyled content. This seemingly simple task of fully utilizing HTML from within a component isn't so straightforward. So let's see how we might solve it today. One sign of a good component is whether you can understand, one sign of good composition is whether you can understand a component's behavior without having to consider all of the other components in your application. We call this concept local reasoning. We can preserve local reasoning by using UseEffect or portals directly inside our article component to insert these tags into the document. But now we've lost these critical pieces of information in our server render. This is even worse than before because bots and other technologies that don't run client-side JavaScript are going to completely miss the title. And the style sheet's loaded even later, so the browser won't be able to discover it until React has hydrated. Really, the only viable path forward is to split our component up. We need our HTML to look like this, with our title and style sheet server rendered and in the document head. So we can provide these tags to the component responsible for rendering the head. But now we have another problem. We have to figure out how to get article-specific information into one of the most generic components in our entire application. We've thrown local reasoning out the window, and we have a complex coordination problem to solve. And whether you solve this problem yourself in your app or you use a library to handle it for you, this coordination is tricky to get right. So what would it look like if we had a React-powered solution for this problem? We started with the premise that this composition of HTML, this composing of our HTML was ideal for component composition. And we also said that this was ideal for our document composition. So in React 19, we set out to make it possible for you to have both. Solving document metadata isn't that complicated. Title tags title tags, links, meta, they're typically only in the head anyways, and so we can just kind of ensure their position there when server rendering, and we just need to make sure that hydration can find them, even if they're not sort of inside the component where it would normally look. But style sheets are a bit more challenging. Style sheets are sensitive to their relative order because later style sheets override earlier ones when style rules conflict. For this, we need a little help from you. In React 19, if you tell React about the precedence of a style sheet, React will insert it into the document head, ordered relative to the other style sheets with a defined precedence. In this example, I have a list component, which renders a style sheet with a precedence that I chose to call default. Precedence is loosely modeled on CSS layers, where later values define higher importance. So now, when I render a style sheet in my article component with a precedence value of high, React will insert it after the style sheet found in my list. But now imagine I have a carousel component which renders a style sheet with the original precedence, default. React ensures that this style sheet is ordered alongside other style sheets with default precedence, even if it was discovered much later in the render. With precedence, React can safely reorder the style sheets to optimize their loading performance, but we still need one more thing to make these really composable. React understands that each style sheet needs to only be loaded once. So even if you have different components that all depend on the same style resource, or you render the same component multiple times, you won't end up with unwanted duplication. But relative order is only one part of the problem with style sheets. Earlier, I mentioned that browsers wait until all the style sheets in the head have loaded before doing the initial paint. This is a critical feature for browsers because it prevents pages from rendering unstyled content or flashing unstyled content on the initial load. But React isn't just about loading initial documents. With server streaming rendering, it might discover a style sheet late, long after the head tag has already been sent to the browser. And on the client, React can discover new style sheets on any update. If React is going to provide a useful capability with style sheets, we can't let flash of unstyled content bugs ruin the experience. So when you use the precedence prop, React will also ensure the style sheet is loaded before revealing the content of the nearest suspense boundary. You can think of this feature as Suspense for CSS. Suspense for CSS works across server components, streaming server rendering, and the client, so you can confidently render your style sheets inside the components that depend on them. React 19 also adds support for hoisting and deduplicating async scripts, another HTML feature that has historically been hard to compose within components. And it also has support for preloads and other kinds of browser hints, with new APIs that can be used both during render and during user events like hover and click. Now, I can probably guess that many of you don't include these kinds of HTML tags or features directly into the components you write for your applications. And that makes sense. These features have historically been very hard to coordinate, and it often took the power of a dedicated library or a bundler to make this feasible. And that's okay. We expect the earliest adopters of these new features to be libraries and bundlers that can remove significant complexity from their implementations. But we hope over time folks will experiment with using these features directly in their applications now that React has made it possible to actually compose them nicely. You can find more information about React's HTML coordination features in our docs at react.dev. And if you want to learn more about how these features work, check out my talk this afternoon where I go into more detail about the problem and how we chose to solve it. Okay, before I wrap up, I want to share a quick update on hydration. In React 18, we launched a new selective hydration feature. And with this, React can hydrate parts of your application and prioritize components that have user interaction, like click events. However, as part of this release, hydration warnings became more prominent and were often frustrating to debug. Well, in React 19, we made two key improvements to hydration. First, React will now make extra DOM nodes in the body and the head. React will be more tolerant of extra DOM nodes in the body and the head, which will improve compatibility with third-party scripts and browser extensions. Thank you. I don't want to ruin the enthusiasm, but hydration errors are still going to happen, unfortunately. And for that, we've made some serious improvements to how we report these errors. Before, when a hydration error occurred, your console repeated the error multiple times, and the necessary information to debug the root cause was hard to find and often not very useful. Now, in React 19, hydration errors are consolidated into a single error report, and most crucially, they contain a diff of the props and the elements that are different. Now, look at this. All right, I hope you're as excited for these new features as I am. Here's Andrew to tell you more about actions and JSX. Thank you.
Good job. All right. Thanks, Josh. Hi, I'm Andrew, and I am also an engineer on the React team at Vercel. I've been working on React since 2016, and it was actually at that year's ReactConf that I somehow tricked them into letting me join the team, so I'm happy to be here again. So let's talk about some more improvements in React 19. The first one we're going to talk about is React Actions. Actions originally landed in the Canary channel last summer, and you may have heard about them in the context of something called server actions, a feature available in server components frameworks like Next.js. But actions are not exclusive to server components frameworks. They also work on the client, even if you don't use a server framework at all. So, what are actions? Actions are a first-class pattern for asynchronously updating data in your application in response to user input. Actions as a general pattern are not a React invention. They've been part of the web platform for decades. In fact, when HTML form actions were first introduced to the web back in the 1900s, JavaScript had not yet been created yet, if you can believe it. Form actions were the way to add interactivity to your web page. And in recent years, there's been a resurgence of actions-inspired APIs within the JavaScript community, thanks in large part to Remix, a React framework, Remix. A React framework whose web-centric and form-centric design has been greatly influential in reintroducing actions as a pattern for server-client communication. Nowadays, it seems nearly every JavaScript web framework has their own take on the actions pattern, and for good reason. We think that actions are a fantastic way to build applications, and they fit perfectly into the React programming model. But if action-based APIs already exist in React frameworks, why are we building them into React? We think we can take actions even further by integrating them directly into React features like streaming SSR, selective hydration, suspense, and transitions, all while maintaining React's obsessive insistence on composability. Our goal is to provide a core primitive that frameworks like Remix, Next, and Redwood can build on top of, the same way they currently build on features like streaming and suspense. To understand how actions in React work, let's go back to the beginning and look at form actions in HTML. So in a classic HTML form, you specify a server endpoint by passing its URL to the action property. When the user submits the form, the data is sent to the server, and the server responds with a fresh HTML page. So submit form, load page, submit form, load page. It's pretty simple, right? And what's great about this model is that you can use it to build almost anything. So why don't we? Because I've seen a ton of web apps, and almost none of them are built this way. Nowadays, a web developer could go their entire career without ever using this API. And what happened is, upon the introduction of JavaScript, we all love JavaScript, if it eventually became possible to build client-heavy web apps that provided a much richer, more interactive experience than apps whose behavior was confined solely to the server. Today, when a user opens your app, they have certain baseline expectations. They expect instant feedback when interacting with the app. There's no time to wait for an entirely new HTML document every time you click. And they expect apps to remember their current state. So you shouldn't lose your scroll position or your text input whenever you perform an action. In other words, users expect more than what's possible to achieve without at least some client-side interactivity. Because of this rise in user expectations, code written for the web went from looking like this to looking more like this. And there are some nice things about client-side event handlers. They can be used to implement instant, rich feedback to user input, and they can compose client and server behavior together. However, they also have some downsides. Managing local state asynchronously is super hard and frequently leads to bugs like race conditions. And because event handlers rely on JavaScript, the UI is not interactive until the code loads and runs, which is slow compared to raw HTML and leads to dropped interactions. So it's tempting to revert back to plain HTML actions. They have a very simple reload everything model that is super forgiving to all your application code, whether it's good or whether it's maybe a little bit sloppy. And they don't rely on JS, so the app is interactive as soon as the HTML renders. But we shouldn't forget about the reasons we moved away from actions in the first place. They provide little to no immediate feedback in response to user input. You're basically just stuck with whatever the browser stock controls give you. And it's really difficult to sprinkle on additional client interactivity because it's an entirely different programming model. React exists to solve exactly this kind of riddle. We've done it over and over and over again. How do we combine the structure and simplicity of server-driven apps with the rich interactivity of client-side apps, all within the same unified, composable programming model? So, how do React Actions achieve this? React Actions are an evolution of two existing APIs. The first is React Transitions, a powerful feature for updating state without blocking user input, introduced in React 18. Actions build on transitions by adding support for asynchronous functions. And the second, of course, is the HTML form API. Using a React action is a lot like using an HTML form action, except instead of passing a URL to the action prop, you can now pass a function. And in the most basic example, that's all you have to do. Pass a function to the action prop, and when the user submits the form, the action is called. By using an action function instead of a URL, you can define the behavior of the action directly inside your component. And now notice there's nothing special about an action function. They're regular functions. You can compose them, you can write abstractions for them, the same way you would any other function. You can define the action on the client, or if you use a server component framework, you can define the action on the server via the use server directive and access your data layer directly. You can have any number of actions per page, per component, per whatever. You can swap out actions at runtime. And we can achieve this level of maximum composability because we've integrated actions into every layer of React, from the client runtime to the streaming SSR renderer to the server component's data format, all working together to provide a seamless experience. You'll notice that in addition to looking a lot like HTML actions, actions also look pretty similar to event handlers like onSubmit or onClick. By convention, we use the word action when naming actions and the prefix on or handle when naming event handlers. Despite the surface level similarities, though, actions have some important abilities that set them apart from regular event handlers. One such ability is support for progressive enhancement. Form actions in React are interactive before hydration occurs. And believe it or not, this works with all actions, not just actions defined on the server. If the user interacts with a client action before it is finished hydrating, React will queue the action and replay as soon as it streams in. If the user interacts with a server action, we can go one step further. It immediately triggers a regular browser navigation, just like a classic web form. No hydration or JavaScript required. Yeah. Another area where actions really shine is in their handling of asynchronous logic. React actions have built-in support for UX patterns like optimistic UI and error handling. These are essential to building delightful user experiences, but they're notoriously difficult to implement correctly due to their asynchronous nature. Actions make these complex UX patterns super simple by deeply integrating with React features like Suspense and transitions. With new hooks like use optimistic, use form status, and use action state, you can start implementing these patterns with just a few lines of code. Later today, we'll get an in-depth look at how to use the new action APIs to improve your app's experience. I'm really excited about those, so stick around. So that's actions in React 19. They're effortlessly composable. They have a unified client and server API. They're interactive before hydration, and you can implement advanced UX in just a few lines of code. So before we wrap up the React 19 portion of the keynote, I want to cover one more topic. Fair warning, this has nothing to do with actions or anything else in the rest of the keynote, but I think it's worth mentioning. React 19 includes a couple of changes to the JSX runtime, and most of them are related to everyone's favorite React feature, refs. Boo! Oh, okay, let's just wait. Well, I'm happy to announce that in React 19, ref is a prop. We did it! This took a lot of work. Okay, so on the surface, this is maybe an unremarkable change, but it in fact fixes a complaint that people have had about React for a while. Because in past versions of React, ref was not a prop. It had special behavior in the runtime. You could pass a ref to a component as if it were a prop, but in the receiving component, the ref would not appear in the props object. And as many of you are well aware, this made it difficult to create abstractions and components that accept a ref, which is a bit absurd given that React, as we all know, is all about composition. The historical reasons for why React treated refs this way are pretty boring. It's related to something called class components. I don't know if you've heard about that. So a few years ago, to solve the problem, without breaking existing behavior, we introduced a workaround API called forward ref. Boo! So mission accomplished, I think. Look, we all know you hate forward ref. It's cumbersome to write, doesn't play that nicely with TypeScript, and it shows up everywhere in your component tree. It's also just a little bit offensive, right? Why is something that should be so simple so complicated? It was the best way we knew to solve the problem at the time without introducing a breaking change. But today, we are finally making that change. Ref is now a regular prop. It appears in the props object, and that means you never need to use forward ref again. All right, that's the end of the conference. I think we can just end it there now. to make this happen, we are removing some long deprecated APIs, including string refs and the legacy context API. We've been warning about these for a while, so most of you are probably unaffected. If you do have an older code base, we publish an upgrade guide with advice on how to gradually upgrade your components. So those are just some of the features and improvements coming to React 19. There's a lot more that we did not cover, but you can read all about those updates on our blog. And speaking of our blog, a few weeks ago, we announced the React 19 beta with a call for library and framework authors to test it out in preparation for a stable release. And so far, the feedback on the beta has been pretty good. So as a result, today, we are upgrading the beta to an RC, release candidate. That's right. That means we think it's stable enough for you to start trying React 19 in your applications. And pending any last-minute feedback, we expect a stable release of React 19 within the next few weeks. And with that, I'm going to hand it back over to Joe to talk about what's coming next in React. Thank you.